Yeah, cool. Let's start. Okay, welcome back everyone. So, we today have 1972 Putnam B6, which is you have a polynomial specified. It's a bunch of monomials with coefficient all plus 1. And you want to show there's no roots at all inside the unit circle here. So this statement is like pretty strong. And probably, do I just use a triangle inequality? is that what's gonna happen? Oh, the add's not up here. Well, I pressed the button, so whatever. It says pre-roll off. Yeah, so here's what we're gonna do. Like, Z decays quickly. So here's my claim. Let's let alpha equals square root 5 minus 1 over 2. Okay? And claim, alpha to the alpha plus alpha squared plus alpha cubed. This infinite sum is exactly equal to 1 because it's equal to alpha over 1 minus alpha. Wait, is that right? No, sorry, this is false. Wait, what is it then? Z is... Okay, never mind. You can't just nuke it like this. 0.618, right? Root 5 minus 1 over 2. Okay. So z plus z squared. It's just like if you have a number, it's like if I have a real number smaller than 0.618, the claim is that there is no way that powers what, really? I'm so surprised this claim is true for like random real number. Is this some Zeckendorf thing? It might. But the thing is, like, this is a strictly less than thing. Right. This isn't true for 0.6. Yeah. Yeah, sorry, this is false. The thing, I thought that it was just going to be like triangle inequality, but it's definitely not. Which is, really? I'm just so confused though. So if I have a... What the heck? So, what's the positive real solution to something like this? There's a positive real solution, right? And it's less than 0.618. Yeah, sorry, no, ignore the thing that I wrote earlier. That was just wrong. Wait, is that? It should equal... Oh, it's -1! Ah, freaking... Okay, okay. Yeah, okay, sorry. It's -1. Okay, sorry, I'm stupid. Okay. So it's like, so for example, this thing, the claim is that the real roots of fall outside the interval. I feel like I want to do the problem for real numbers because probably the triangle inequality will then imply it for complex numbers. Like, yeah, should be some Zeckendorf. What's the solution to r plus r squared equals -1? Is it like... No, that doesn't do anything. Sorry, you're right. Yeah, it said 1 earlier, and then I realized I was being dumb. Let me relay this. Okay, what's like the thing though? Like so z plus z cubed plus z to the 5th. Is the equality case this when like it's equal to odd integers? This is equal to z over 1 minus z squared. So this does indeed give this will give things that get arbitrarily close. Yeah, because this will get 0.618. No, it won't. Z squared plus... I'm being dumb. If you want more in-depth analysis, I mean, there are standard textbooks, like Rudin. I have no idea what I've never actually read Rudin. Did I not acknowledge the cheer? Well, thank you 88 Brilliant for 300 bits. And also shout out to Why You Ignore My Cheer, rip from 88 Brilliant. I thought I acknowledged it. Maybe not. I'm confused why I'm not getting... Wait, can I just not solve this? Okay, this is z squared minus z plus 1 equals 0, right? Is that the one? No, it's still plus root 3. So where's the root 5 coming in? The solution to this is... No, this is minus. I am just doing all sorts of goof today. Can't. Okay, and this has the solution I want, right? The negative solution is z 1 minus root 5 over 2. Okay, so that's sort of where we think this is coming from the real numbers. For reals, okay, so that's where the bound comes from. Now, for real numbers, this would almost work. And so for complex numbers, I want to do something with the argument, I think, to say that, like, to bound it in this way. So... yeah, I think the second order thing is correct. So here's what we're gonna do. Like, we're basically doing triangle inequality, and what I want to say is, can I look at the real part? That doesn't quite, does it work? Z plus z squared, and then times z to the k. So assume for contradiction, z is a root, blah blah, and I want to bound. So for the real numbers, you can distinguish between positive and negative, and that's what makes it work. For complex numbers, you have an argument. There's this complex argument, but like z plus z squared. I guess if like z is close to this sucks. Yeah, I feel like I want to look at the real part. Can I say anything about the real part of z plus z squared for z inside with z less than like root 5 minus 1 over 2? Like the real part of z plus z squared. I wonder if Twitch chat can show the latte correctly would help. I don't know if that's possible. So I wonder if it's the case that real z plus z squared for z inside this circle should be bounded, because it's like yeah. I wonder. So real z squared, and then real z plus z squared are sort of the two things at play. You know, I feel like I should be able to do this. Okay, let z equals r cos theta. Yeah, I think I don't have a. So real z plus z squared is equal to r cos theta plus r squared cos 2 theta. And there's sort of two parameters, but we think that the cosine is like at most worst one anyways. So let me just look at these two numbers and see if this does what I want. So r cos theta plus r squared times 1 minus, what's the double angle from 2 cosine squared minus 1, right? And this is basically, let's call this x plus yi. So this is equal to x plus 2x squared minus 1. And we want to lower bound this from below, with the equality case being when x is actually the negative thing that we... I feel like I made a mistake. Something doesn't feel right. Oh, you did. You have to be a little more global than pairs. Because if argument z is close to 0, you can have a bunch of pairs, which are... I see. Yeah, you are correct. I don't want to take just consecutive. Well, I don't know. Because the thing is, if they're close to 0, then by the time they flip all the way to... those things seem pretty small. Or I don't know. Okay, yeah, you're right though that I can't bound it by individual pairs. Can I? The other thought I had is that you can try to we're sort of bounding this. The other way you can think about it is we're bounding the sum from k at least 0 of r to the k times the larger of negative cosine k theta and 0. And the goal is to show that if R is, so let me, I think this part might not work. And we'd like to show that this thing is less than or equal to 1. So for R less than, R is positive here, and if R squared plus, then this is true. Okay, so because of this, we might as well actually replace R with root 5 minus 1 over 2. Because that will, the left hand side consists of non-negative sums of R anyways. So forget R. Yeah, we can put it directly into here. So we would like this thing to be true for any angle theta, and we know the equality case is if theta is 180 degrees. Signum. What is signum? Sine function. Sine function. So actually, I'm curious about this light tag for Twitch chat. This is a local extension, right? I see. Yeah. The thing is, so on my end, it's the chat you see at the bottom of the screen is not a browser, so I think. Yeah, I'm not totally sure I can implement it on the bottom easily. However, yeah. Yeah, it boils down to this inequality in terms of parameter theta. We sort of don't really care about the root 5, because once you phrase it this way, you might as well maximize it. So the question is like, how can I get... Sucks. Max of minus cos k theta and 0. Shout out to Jesus for dying on the cross for our sins from a pink rabbit. Okay, theta. But I almost feel like if theta is... What's the threshold for theta for which I can just throw away, like I feel like if theta is small enough, then, like, the inequality just might be true without much work. Because the exponential decreases really fast. So if theta is, like, not close to 180 degrees, it feels like it should just kind of be true. If theta is close to 180, you need to be a little more careful. R squared plus R cubed plus R to the fourth. That is correct. Okay, so yeah. Let me just directly let alpha equals this thing. Then so alpha squared plus alpha cubed is usually at minus alpha. Yeah, family friendly. Yeah, I wonder here's a question, like, is there, for which values of theta does the bound, like, let's say alpha cos theta plus okay, here. Like, for example, because alpha squared plus alpha cubed plus this is one exactly. If, like, theta is less than whatever it is, 90 degrees already done, for example. Well, let's say assume 0 between theta between 180. So if theta is less than or equal to 90 degrees, we don't even care. Like, we're already done. On the other hand, suppose we have the first term, so alpha cos theta, but you don't have the second. Like, what I'm thinking is maybe there is a way I can, like, come... It's alpha squared. Wait, what? Oh, it's not true? Wait. So what is sum of alpha squared? Oh, Jesus Christ. So the characterizing property is alpha squared plus alpha is equal to 1. So is it not true? I'm very confused. Isn't it alpha squared over 1 minus alpha, right? I think it's fine. Okay, cool. So what I'm thinking is like, what is it? Are there any more thresholds? Like, because for example, if theta is, you know, just slightly over 90, the first term is going to be really small anyways, and the next term isn't going to be that much larger. Like, is there an analogous next statement that will give me another threshold? Is it possible to solve JMA 2018-6 without divine inspiration? What if I told you the answer was no? What would you do? He would be inspired. So what if theta is, let's say like what if theta is less than 135 degrees? And then alpha and alpha squared are both, the first and second term both contribute, but it's like pretty dampened, right? Because your cosine value is like not that good. So this is something like you get x plus 2x squared minus 1. And then you can say maybe like alpha cubed plus alpha to the 4, whatever. Is this going to be bounded? So x is at most alpha times square root 2 over 2 or something. So I don't actually know if this is bigger than 1 or not, but I'm curious, because if this works out, then I think this might be a line forward. But I have no idea whether it's going to work out. Calculation seems not very fun. Hang on, also I think I also screwed up. It's alpha squared times 2 cosine squared theta. Let me just write it out explicitly. This minus sign is so obnoxious. Let's give this sum a name. Let's call it S. So we want to see, is this worse than before? So the question is, can this thing get to alpha? Is this like less than or equal to alpha squared? I actually don't know. Is this negative? Yeah, this is... Cosine is pretty small, so it's negative. But if this cosine is small... So here's my question, if... Oh, crap. It's so not intuitive to be working with a negative number. If theta is 90 plus epsilon, that is bigger than alpha squared. Really? Oh, you're correct. Yeah. Okay, so this line of thought won't work. Dang. Yeah, I agree this line doesn't work out. Yeah, I agree it doesn't work, but you can't just dumb down the first two terms. I hate the cosine. Can we like... Maybe the first three. So like there's an inequality that says sine of x is less than or equal to x. Can I apply that like around here? What's the analogous thing for cosine? There should be like an estimate for cosine in terms of like... It's what happens when I take the thing and truncate it. So for, I want an estimate that's good for cosine near 180. What is that estimate? Yeah, so it doesn't fall faster than x squared. So cosine of 180 degrees minus x, let's say negative of that, is equal to... Well, it's actually equal to cosine x exactly, right? Okay, so first of all, let me do the... Wait, hang on. No. What am I doing? Can I write this inequality in terms of positive numbers? Because I really hate the negative. Yeah, but the problem is when you double it. This sucks. Okay, you know, I'm sick of working with angles near 180. So suppose z has argument 180 degrees minus theta, then this is minus 1 to the k. Okay. Okay, this is slightly more humane. Here, clear everything up. Consider minus 2. Oh. Wait, what? So you're saying, suppose you have a given thing, so by negating it and also using the fact that z plus z squared. I'm very confused by the recent comment. So I consider that thing, then expand. Yeah. But see, z plus z squared plus z cubed and so on. So if z is a root, then okay. Well, let me think this through. So if minus 2 1 plus z, okay, the thing that's given, and if I add that onto z plus z squared plus z cubed, and then I get like plus minus z squared plus minus blah blah blah. So if z is a root, then this promises what? Okay, well, first of all, there should be a minus 2 here. There's a minus 2 here. I think my question is, does this preserve the equality case? And I'm a little skeptical. Well, actually, no, hang on. Sorry, I take that back. I'm just confused. What the heck? What's going on? So And this promises that z plus z squared plus z cubed equals... So on the one hand, this is z over 1 minus z. On the other hand, this right-hand side is equal to... So, I mean, the right-hand side is, I don't know. Ah, dang. I think I can delete this part now. I don't think this part is going anywhere. I wonder if I can do some crappy like interval argument or something. Like the first suppose the first n terms are positive or something. Or that doesn't work, sorry. I mean it's like sort of alternating up until a certain point, right? And then it might like hiccup or okay. The other thing is being claimed to have a counterexample, so I'm gonna hide it for now while I won't delete it. But I wonder, so... Like if I say theta is like... Like when theta is a small angle, how do I bound things? And actually, for that matter, if theta is a large angle, like if theta is like 98 degrees or something really bad like that. Well, 90 degrees is a terrible example, actually. Wait, no. Okay, alright, let me put it back. Okay. Pray for Mount Evangeo to erupt on Yusumo. No comment. So, okay, what? Alright, let me figure out. So, on the one hand, you have that. On the other hand, so how am I bounding the right-hand side? Alright, okay. Wait, so I'm still confused where this bound is coming from, though. So you have z over 1 minus z, and then what do I do with this? Do I just, like, say this is, like, a most... Just bound by triangle inequality. So, what, do I take absolute value of both sides, and then, like... Okay, I'll take absolute values of both sides. So z over... I'm just confused where everyone's getting the 2. Like, people keep talking about this too. So this is 1 minus z. And this is equal to, like... This is less than or equal to 2 plus... Move the 2 to the left-hand side. Okay, so I'm... fine. You guys want me to move the 2 first. That's okay. So 2 plus 1 minus z... Is this gonna work? God. So 2 minus 2z, 2 minus z over 1 minus z is equal to z plus... Welcome back, Taper. Alright, and so I take absolute value and bound with triangle inequality, right? So you want 2 minus z over 1 minus z. Well, it's known by triangle inequality to be MOZ plus z squared plus so on plus n equal to 1 over 1 minus z. Or sorry, z over 1 minus z. And the claim is that if z, the absolute value of z is like too small, this is a contradiction. Desmos has changed since I last met it. Okay, so... Okay, we'll score both sides. So 2 minus z squared. So both sides are non-negative, so we may square. And so this is 2 minus z bar over 1 minus z. And then 1 minus... I thought I said I wasn't doing useless try and wait, did I say that? I think I've said that in past years. Mostly because I thought it would be awkward for like me to be like the editor-in-chief talking about like the use mode that I like set. So in past years I was kind of worried about it, but now AOPS is just hosting the use mode altogether, so I'm like, okay, it's probably fine. Yeah, so, okay, simplify right-hand side. So right-hand side, if z equals x plus yi, this is 4 minus 4 times the real part of x plus z squared 1 minus twice the real part plus z. Okay, at this point I'm just going to write r instead of r for z, x plus yi. So let z equals okay, so this is also r squared. So now I want to check this inequality, right? And first of all, what I want to do is like not have to deal with x first of all. So this is equal to 2, wait. Ah, frick, yes, 1 minus r squared squared. Oh, jeez. That's not good news. I didn't want to see 1 minus r squared r squared. Okay, so subtract off 2. So 2 plus okay, is that right? Okay, and then since x is at most so since x is at least minus r, it is sufficient to prove Evan, stop FCK and ignoring and read chat. No, there's stream delay is the thing, right? Like I'm... Did I not fix it? It is 1... Oh, wait. Wait, how is it 1 minus r? Oh. God freaking... Okay, I see. Okay, so it's sufficient to prove with x equals the worst case minus r. Oh, okay, actually, since we're going by contradiction, I actually want these to be forward arrows. So let's see, if I want to make this smaller, I want this denominator to be as large as possible. So 1 plus 2r plus 2r squared, right? So okay, actually I won't be sloppy, I'll say which ones are if and only if. So everything up to there was if and only if, but, well, the triangle inequality is not if and only if. So this one implies. And then this one is also. This one also implies. X is around 2r. Wait, how is x around 2r? Isn't r the absolute value of z? So why is x around 2r? This one is not because I replaced x with something smaller. X is around minus 2r. Why is x around minus 2r? Am I crazy? Like, x is the real part of z, and r is the absolute value of c, so I don't just see how... Okay. Yeah, so alright, so now we do the very important skill of expanding. R squared, 1 minus R squared, plus R squared, 1 plus R squared. Okay. Okay, so 2 minus 2R squared, or 4R squared plus 2R to the 4 plus, oh, Jesus Christ. Alright, calculation! Where did the 1 minus R squared? Well, I multiplied both sides. I cleared all the denominators. Yeah, because this bottom is 1 plus R all squared, and this is 1 minus R all squared. Okay, so please tell me, yes, the 4th degree term cancels, which is the important part. Okay, so let's move everything, alright? So these two are if and only if. And so let's see. There's no R to the 4th term. Is there an R cubed term? There is plus 2. There's a minus 2R cubed. Okay. Minus 2R cubed plus something R squared. What's the R squared term? I get minus 1 here, plus 2, so this is plus 1, minus 3, plus 5? Oh, there's gotta be something wrong. Your right hand side is, oh, sorry. Okay, great, minus, yeah, okay. Okay, so it's quadratic. This is tight and true. Alright, so what's the R squared coefficient? 2R squared minus, so this is minus R squared, minus 5 plus 4, so this is 4R squared. What is the R coefficient? It's contributed just by this. It's plus 4R. Oh, well, okay. We know what it's going to be, right? Hey. Yeah, see, the monitors helps because it means I don't have to switch windows, but I can still only look at one monitor at a time, despite the fact I have 2 eyes, you know? It would be nice if, because I have 2 eyes, I could look at 2 monitors at a time, but I don't think this... Yeah, also we solved the problem. We're done. We're done! We're done! I feel like I don't know what happened here. Like, this feels a little black magic-y. Basically what we did was we recentered the series, I think, around, so, I mean, suppose Z is a root, right? Then what I do is I add in a copy of this thing, which I know, like, so that the, you know, now it's like a mixed sign thing. So it instead becomes trying to show this thing is like not equal to this thing with mixed signs. And then somehow that works because now the absolute value is, motivated for the right reasons. Yeah, I agree, Z, that's the one, yeah. Yeah, I agree, Z is absolute value, that's the one. Tough. Alright, well, let's add that in. Okay. Okay. I think this is more clear if I just write equals z over 1 minus z here. So this arrow is actually if and only if. What should I change stream title to? Wow, what a creative stream title name. All right. Okay, so okay. So if r is equal to root 5 minus 1 over 2, then r plus r cubed plus r to the fifth plus so actually okay, I think this fraction should just be r over 1 minus r. Alright. Oh, frick. New line. Okay, amazing. Yeah. So my feeling is that yes, LaTeX is good. So I guess what I should do is, because I can't get it on my end, but I figure the viewers who are in the stream might want to have LaTeX support. So for remark, isn't it -1? Ah, freak, yes! Good catch. Right, where was the link to that extension? I had it open a moment ago. Okay, so what we're going to do is we're going to make a new Nightbot command called LaTeX, and I'll link to that extension. Okay, so let's try that and see if that works. Okay, that looks like it's working. I'll add it to the stream title so people know it exists. Okay, great.